This lesson is going to be on Island Biogeography, Unit 2, Topic 3. So let's start with the basics. Diverse habitats lead to more biodiversity. And the loss of habitat leads to a loss of biodiversity. This is fairly obvious in things that we've been talking about all along. Specialist species are the most at risk for extinction from habitat loss. They have a very specialized set of requirements to live under. And islands create unique systems for studying environmental principles. So island biogeography. It was originally developed by Robert MacArthur and E.O. Wilson in 1963. And the main question was, why do different islands have different levels of biodiversity? The theory boils down to these two things. The larger the island, the more biodiversity, and islands closer to the mainland have more biodiversity. So here's some islands. Islands gain species through multiple ways, but one way is through colonization. The odds of hitting land are small. The further the island is, the less likely you are to hit it. So think about organisms that are traveling. The further they have to travel, such as to Island A, the less likely they are to get there. Small islands have less space and resources. There are fewer niches that need to be filled. So there's a lower speciation rate and lower biodiversity. Just because an organism makes it to an island doesn't mean that it's going to have the right set of conditions for that organism to survive. So just making it there doesn't necessarily make it live. A larger island would have more resources. The unique habitat and resource availabilities on the island lead to different speciation events. These often create specialized endemic species. So endemic means a species that has a very limited range, often limited to just a few locations, like the koala. Koalas are endemic to Australia. And then also think of Darwin's famous finches. So each island had unique conditions, and his finches that he was studying all had one common ancestor species, but the finches had adapted to meet the needs of their home island and eventually became their own species. Since these are specialists, any change to the island can be catastrophic. One of the most damaging disturbances is the introduction of invasive species like cats, pigs, and especially rodents. These are all generalists, meaning they can survive on a variety of things and often outcompete the organisms that live on the island, which are often specialists. So let's take a look at this graph. And so if we look here, we're looking at the rate of immigration or extinction. So immigration is in blue, and we have distance to mainland, far and near, and then the island area is small or large. And the easiest way to sort of read this here is if we look here, where, let me draw a line. So if we look at this intersection here of birth and death rates here, so immigration and extinction, when the island is near and large, this is where you have a lot of species presence, because this is what we're measuring here. And if we look at this intersection here, we have an island that is far and small, so we have a fewer number of species because our species increase as we move across. So we look for the intersection of those two lines. It would make sense that in between would be large and far and small and near islands. Islands aren't necessarily islands. Gosh, what does that mean? This theory of island biogeography can also apply to habitat fragmentation. And that's really important in what's happening to the Earth today. Take a look at that. We've clear-cutted that forest and left that one patch in the middle. That's an island in some senses. When a continuous undisturbed habitat is split up into smaller fragments due to natural or man-made events, that's habitat fragmentation. An island, therefore, can be considered a patch of high-quality habitat surrounded by low-quality or insurable habitat. So we have, this urban area around this patch in the middle. The smaller fragments would have lower biodiversity. And here's Central Park in New York City, like we talked about. It's huge and it's large, but it is isolated. So it is an island So human development has created a more fragmented habitat for wildlife to deal with. And so we can link those fragments. There's methods of improving this patchy ecosystem, such as ecological corridors, keeping this here in this farmland so the animals have a place to travel or a way to travel. Smaller patches of suitable habitat that allow species to island hop from one large island to another. Can take the form of a parkland, physical structures, or even personal gardens. Yellowstone to Yukon focused on creating a corridor of safe habitat to allow large animals to move from place to place. So if we look down at Yellowstone down in Wyoming and all the way up to Yukon up in Alaska. And this was accomplished by using some protective lands, some conservation lands. Clearly it's not a perfect corridor, but in between federal and state parks for other parcels like private nature preserves, farm fields, and wildlife overpasses. Take the fractured parks and sort of link them together, and it helps boost biodiversity. So to recap, islands are unique habitats with limited resources, leads to the evolution of unique and specialized organisms. The theory of island biogeography states that islands that are larger and closer to the mainland will have higher biodiversity. This theory can also apply to habitat fragmentation. And wildlife corridors are one means to link patches of habitat and increase biodiversity.